Okay, so this is the sixth lab for this course. We're going to be working with this valve today here. We've got a positioner installed on it. So we talked about positioners in cascade control. And we're going to be comparing the valve to operation with and without the positioner. So the way that this is set up right now, I have the discharge of our pump. You can see this line here, it flows up. And then it goes into our valve here, out of the valve, and over and into our mass flow, our Coriolis flow meter here. And then out of the Coriolis flow meter, it flows down and back into our tank. And so the just continuously cycles. So we're gonna be measuring, we're gonna be applying a pressure to the actuator of this valve. It's a fail closed valve to get it to open. And we're gonna see what it does on the way up and then on the way down. And we're gonna record the flow rates. And those flow rates are gonna tell us the position of the valve. It's going to tell us, if it goes back to the same position each time. Because if it does, we should get the same flow rates when we apply the same pressure. And so to apply this pressure here, we've got a three-way valve on here. And so what this three-way valve allows us to do is when the valve is turned this way, it will take outside pressure and put it right into the actuator here. And so in the first part of the lab, that's what we're going to be doing, is we're going to be connecting our pressure from a regulator into here and bypassing the positioner and going directly into the actuator to open the valve. So the pressure that comes into this fitting and over and into the actuator is going to be coming from, I had to get this regulator right here, which will be getting air from our bench down here, plumbed into the regulator. The out of the regulator will go into our gauge here, and then out of our gauge will come back over here. And so what this allows us to do now is we can record the pressure on our gauge here. And so we're going to go, it's approximately 3 to 15 psi bench set on this valve. That means at 3 psi we're fully closed, and at 15 psi we're fully open. So we're going to be starting at 3 psi, working our way up to 15, might go a little bit above if the valve keeps opening, and then come all the way back down to 3 psi. So we're going to see if there's a difference from the up stroke and the down stroke when we're just strictly applying pressure to the valve here. And so that's how a control system would work without a positioner. The controller would send a signal out to the valve, a pressure signal out to the valve to control it. But the positioner is like a controller, a position controller, right? And so then after we apply pressures and bring the open and close the valve, then we're going to source a milliamp value. And I've got this hooked up already because I was testing it. So we've got current. These wires here come from they connect into our positioner here, and they come down and over to, we've got a Fluke 725 here where I can source a current, a 4 to 20 milliamp current here. And I just move these buttons up and down here, and you can see the current changes right there. And that's going to open and close the valve. So when we do want to do that, we're going to have to supply gas to the positioner here, or air to the positioner. And our valve needs to be in this position. So supply comes in, positioner measures the position of the stem of the valve, and then the controller, the positioner, outputs a signal to change the pressure to make sure that the valve goes to the correct position. So we're going to start things off first by doing an up-down test using the pressure regulator, and then we're going to do an up-down test using the Fluke 725 here, sending a signal to the positioner. And we're going to compare our results. So hopefully it makes sense. We're going to see the benefits of using a positioner. The pump on here, and I've got the flow rate being displayed here, kilograms per minute from our mass flow Coriolis meter. We're at about 0.35 kilograms per minute. You can see there on the display, 0.35. We're going using 2 decimal places, and I've got 3 psi here. I'm actually going to show you here. The valve is probably closed. Bleed this off. It's at 0, and you can still see it's still reading the same value there. Likely our meter needs to be zeroed, but I'm just going to bring this up to 3 psi now. So we're in this part of the test here, we're going to be approaching our values our pressure values from the bottom here. So we're gonna go up to 3 psi. And this regulator is kind of finicky. There, right at 3. Slightly above, but right at... Just try to back it off a touch. There, 3. And you can see we're still reading the same value. So that's the flow rate we're going to enter in here at 3 psi, 0.35. And I'm going to do this. I'm going to go up to 4 now, up to 5. So we're going to approach all these values from the bottom. And then we're going to do it again going down here. So this should be a kilogram per minute here. And so we're going to get up to about 19 is where I saw the flow stop changing. And then we're going to come back down here. And we're going to see here if this valve has any stiction. All right, so I'm just on my way back down here. You can see I'm at 6 psi. And I've got a flow rate. It just slightly dropped, but at a flow rate of 2.3. Yeah, so we're still at about 2.3 kilograms per minute here. So just on our way down here, you can see. So now I've got I've just started doing a few readings here. I've got our positioner now connected here. So our positioner is this positioner here up inside our valve here. It's sensing the position of our stem here, and it's acting like a position controller. So it ensures that the valve, when we input a certain current value to it, it ensures that the valve goes to 7.7% open. So what we're doing is we're going to be running it up from 4 to 20 milliamps. And right now I've done a couple readings here just to check to make sure things were working. And I'm going to keep on going. So I'm on my way up right now. I'm going to be going to 10 milliamps here. 10 milliamps. And this is like 0 to 100%. I guess I could add that there as well here, just so we know the corresponding percentages. So I'll do that. But I'm going to go and figure out all these values. And then I'm going to work my way down here as well. And we're going to compare our results to using the positioner versus not using the positioner over here. Over here we were just changing the pressure in, but the positioner is going to manipulate that pressure to make sure we get the correct position. All right, so I've completed the up-down tests here for we did it for by changing the pressure into the actuator only, and then we varied the milliamp value on the Fluke 725 here. I added the corresponding percentages here that it should be at. I think our positioner was slightly off. It might need to be calibrated, but either way, it should bring it to the same position each time. And then we ran it up and then ran it down here. So we got up, down tests and recorded flow rates there. And then what I did down below here is I took that data and I plotted it on a graph here. And so what we can see over here on the positioner, they pretty much overlap each other. They went pretty much the same position if you look at this on a graph. Whereas when we did it with the regulator on our way up here, they didn't go, the flow rates weren't quite as high as they were on the way down over here. You can see this is flow rate over here, and this is pressure, PSI, on the X. Over here, this is milliamps on the X, and this is flow rate over here on the Y-axis. So with this information, you should be able to answer some questions that I have posted for you. So there we go. We've compared the difference between using a positioner versus a regulator.